Unacademy. Let's crack it.
So in this session I'd be asking you. So this will mainly be a problem-solving session first of all, and the agenda of this session is actually to see the problems asked in Amazon's interview. Okay, so these problems were asked to one of my friends who was interviewing for a SDE1 position. Okay, so I haven't taken all of the problems, but I have taken the whatever good problems were there. Some of the problems were actually easy, so I have just skipped them, and some of them we have already solved, so I won't be taking them. But here we would be discussing the best of problems that were asked, and also those problems which we haven't yet done. Okay, so that's the agenda of this session. This would mainly be a problem solving session. Okay, so we would be seeing three problems in this session. Okay, so two of them are, you can say, lead code medium or lead code medium hard problems, and one of them is code forces diff 2 c, or you can say lead code hard or slightly harder than lead code hard. Okay, but if you know the concept, then I think by giving spending some little amount of time, you'll be able to solve it all the three problems. Okay, and the first thing I would like to tell you is that whatever concept we have covered till now, okay, so graphs, dynamic programming, recursion, binary search, and whatever concepts that we have covered till now are sufficient to be able to solve all of these problems. Okay, so let's get started. So for those of you who are watching my videos for the first time, so my name is Anuj Kumar Singh, and I am an incoming software engineer at Google. Prior to this, I have interned at Google, and I have also interned at HackerRank. And coming to my competitive programming profile, I have been doing competitive programming for around 3 to 4 years. Okay, and I'm a candidate master on code courses and a five-star rated coder on Codechef. Okay, so that's all about me. This is question one. Okay. Let me write the question first, and then I will explain it with examples, and then I will give you time to think, and then we will discuss the solution. Okay. So let me just write the solution. Given an unsorted array of integers, return the length of longest consecutive element sequence. So let me write out the constraints as well. So n is less than or equal to 10 to the power 5, and a of I less than or equal to 10 to the power 9, or minus 10 to the power 9 to 10 to the power 9. So these are the questions. Okay, so I will not be directly telling you the question, since in interviews you need to ask whatever you don't understand. Okay, so I am writing some input output, and I would just very briefly explain the question to you guys. Okay, so suppose your array is, let us say, 100. So yeah, Pavan, I would discuss that. Don't worry. Let me just write the question. One. Okay. So suppose this is your array. So let me explain the question in brief. If you guys have any questions, then you can ask me, and like that's how it goes in an interview. So what you are actually given is an unsorted array of integers. So first word that you should see is that it is an unsorted array. Okay, you need to return the length of the longest consecutive element sequence. Okay, so now like you can just ask the interviewer what is the what does he mean by length of longest consecutive element sequence. Okay, so let me tell you what does it mean is, see, here I can take these elements, one, then I can take two, then I can take three, then I can take four. Okay, so all of these are actually consecutive elements, right? So the length of the longest consecutive element sequence is actually 4 in this case. Okay, if you want another example, so let me give you another example as well. Okay, so for this example, the answer was 4. But let us see another example. So suppose it is like 5, 4, 0, 1, 2, 10. Okay. So here you can see the longest subsequence, the longest sequence would have, we have 0, then next is 1, next is 2. Okay, so here the answer is 3. Okay, so see, it may, like you can, it is not necessary to include only adjacent elements. Any elements can be from anywhere. So here you can see that 1 is here, 2 is over here, 3 is over here, 4 is over here. Okay, but the only constraint is that the element should be consecutive. Okay, so if you are starting, 1 is there, 2 is there, 3 is there, and then 4 is there, so all of these are actually consecutive. If you actually write, like see, check them, that 1, 2 comes after 1, then 3 comes after 2, 4 comes after 3. Okay, so when we round write the counting from 1 to infinity, they are in consecutive order. Okay, so you need to tell what is the length of the, what is the longest consecutive element sequence. Okay, so just tell me if the question is clear to you guys. Okay, so let me give you another example as well. So suppose your array is, let us say, 1, 4, 3, 10, 20, and let us say we have 5 again over here, and 6. Okay, so here you can see what would be the maximum length. Okay, so let us say we have 2 here as well. Okay, so what do you guys think will be the answer for this sample test case? Okay, so Sanya, uh, we don't see, 1 is over here, 2 is over here, 3 is over here, and 4 is over here. So the sequence is actually 1, 2, 3, 4, and all of these are consecutive. That is what I mean. Is it clear now, Sanya? Okay, so we, so for this the answer people are saying is 6. Can you guys tell me how the answer is 6? Yeah, Pawan, your answer is correct. Okay, so here you see 1, 2, 3, 4. Okay, yeah. We have 5 also over here. I forgot. That's why it has 25. Okay. So yeah, you can see that we have 1 over here, then we have 2 over here, then we have 3 over here, we have 4 over here, we have 5 over here, we have 6 over here. So answer is 6. Let me give you another example, that let us say it is 10, 11, and let us say 9, 13, and 15. So what would be the answer for this case? 3. Okay, so 9, 10, 11. So why did I tell you this sample test cases? Because some of you may think that the starting point is always 1. Okay, that is not the case. It can start from anywhere, but the only constraint is that the elements should be consecutive. Okay, so I hope, and these are the constraints. The constraints I have written over here. That is, n is less than equal to 10 to the power 5, and ei is from minus 10 to the power 9 to 10 to the power 9. Okay, so you can have negative numbers as well. Okay, and let's start discussing. So what do you guys think will be the brute force solution? So Kushal, okay. Yeah, Kushal, since you already got the solution, try to think of a more optimal solution than that. Okay, so consecutive means one after the other. Say like in counting, when you write 1, then after 1, 2 comes, then 3 comes, then 4 comes, then 5 comes, then 6 comes, then 7 comes. So you actually need to select some elements from here. So like here you can see I selected 9, 10, and 11. So they are consecutive, right? If I write them out, first I have 9, then I have 10, then I have 11. So they are consecutive, right? That is what I mean. Okay, that is the difference between the adjacent elements is actually equal to 1. Okay, so like what would you do after sorting the array? Gautam, sort the array and check if number difference is by 1. Okay, so Gautam, yeah, we can do that. What would be the time complexity of of the solution when we are sorting it? Okay, so Mahavir, Gautam, Pavan, and Donev, all of them have actually told us same solution, that we can sort the array. So what would be the time complexity of your solution? So Kushal says put into map. Okay, so can you elaborate your approach? Use the same sorting approach. Yeah, the approach is correct, but can you tell the time complexity? After sorting, maintain two variables. Current, yeah, correct, Mahavir. Sort the array and traverse the array to find the longest length. Correct. Okay, so n log n plus n. Correct. So Siva, how is the time complexity on by using the sorting approach? There would be a n log n factor for sorting also, right? So most of you have said that the time complexity would be n log n. Okay, so the first and the very obvious solution is, so suppose your array is, let us say, this array 143, 1, 4, 3, 10, 20, 2, 5, 6. And we had 20, and we had 2, then we had 5, then we have 6. Okay, so if you sort this array, so it would look like 1 would be there, then 2 would be there, then 3 would be there, 4, 5, 6, 10, 20. Okay, so now you can just uh, check that all of the element that would be consecutive would be adjacent to each other. Okay, so you can start from here. So one, two can be there, three can be there, four can be there, five can be there, six can be there. Okay, so now I see that is seven the next element or not. So I know that seven is not the next element. So this series can no longer be continued, and I see that I got a answer of length six. Okay, then I start from 10 again. So I check that is 11 present. So I see that no, 11 is not the next element. So this is a single series, and similarly for 20, this is a single series. Okay. So finally, I find what the maximum of all of the length of the series is. So I find that the answer is actually 6. Okay. So Kushal, see, all numbers are distinct. So Kushal, you tell me, does it matter if the numbers are distinct or not? Okay, yeah. So if the numbers are not distinct, then you would have to slightly modify your approach. So you can actually store them in a set and like make them unique. Since the answer won't change if the numbers are distinct or if they are not distinct, right? That is what I mean. Okay, so Sonia says we can store them in a boolean array and check them in a loop if it is a continuous, then increase count, and then whenever we get zero, we reset the count and store the max. So like, how would you store in a boolean array since you the elements are negative, positive, and are of the order from minus 10 to the power 9 to 10 to the power 9? So I don't think you can make a boolean array. So Pawan says, sir, in interview, should we need to tell brute force approach first? Yeah, it is actually better to tell the brute force approach first, since it gives the interviewer an idea that you actually started from the very basic and then built your solution above it. Okay, so that actually also actually tells the interviewer that you have a good understanding of the problem as well as the different variety of concepts that you can use to solve this problem. Okay, so Mahavir n log n. Yeah, n log n will pass. I'm not saying that, but can you find a better solution than n log n? Okay, so Kushal, see, EI is from minus 10 to the power 9 to 10 to the power 9. So you won't be able to make that large an array, right? Sir, what if we know that question before and we know it's optimal? Okay, so see, if you know the question before, still it is better to start from the, see, it depends on the interview time that you have left. That's the first thing. So suppose this is just the first question that the interviewer asked you, and you know that the interview is, let us say, of 45 minutes, and the interviewer is going to ask you two questions. Okay, so you can actually ask your recruiter to tell you like what would the round be like, what would be the duration, and what topic can the question, what type of question can be asked, whether it is a DSA round or a system design round. Okay, and you can also ask like how many questions would be asked. So like they easily tell that yeah, two questions would be asked and it would be a 45-minute round. Okay, so based on that, so suppose this is the first question. Okay, so you can easily start from the brute force approach, and since you obviously know the complete logic from before, it won't take much time to even start from the brute force approach. However, if this is the second question and 30 minutes have already passed and only like let us say 10 or 15 minutes are left, then I would say that go to the optimal approach directly, since they would also ask you to code it out and you don't have that much amount of time left. Okay, and this is actually a problem that is copied straight away from lead code. So let me write it out in short. So what are the solution that we got till now is actually n log n, and this we do by using sorting. So this is the solution that we have till now. Okay, and someone said that we can make a frequency array, but we can't make a frequency array since the element range is actually very large, from minus 10 to the power 9 to 10 to the power 9. So try thinking of it. It is actually, see, uh, if you are not able to get this problem, try seeing how you can brute force this solution. How you can first try to think that how would you apply brute force for this question. So if you try to think of the brute force, it is actually worse than the time complexity is actually worse than sorting, but that would actually help you get an ON solution. See, I gave you a question. You directly thought that yeah, sorting could be used. Okay, so sorting is actually n log n. Okay, and I am telling you that I need a ON solution. So obviously I can't convert this sorting solution to an ON solution, right? So I would forget about it. I would completely forget that I actually got the solution for this question, and I would start thinking from the very basic again. Okay, so try thinking of some different solution. So can someone tell me how would you brute force? How would you solve this using brute force? Okay, so we can use priority queue. So still it would be n log n only, right? For A1, we search for A1 plus 1. Correct. Store values in BHT and traverse it. Okay, so that is also n log n only, right? Insertion in BHT on in the worst case is actually ON, so that can even be O of n square. Hi Tisha, let me just. Oh yeah, Kushal, your brute force solution is correct. Now try to think, what is the problem with your brute force solution? Okay, so hi teacher, let me just briefly explain you the question again. So we are actually given an array A. So this is our array A. Okay, and it is an unsorted array. And you need to tell what is the length of the longest consecutive elements sequence. Okay, so what does it mean is, so suppose this is your array. So I can take this sequence 1, 3, 2, 4. So what are the elements in this sequence? 1, 2, 3, 4. All of these are actually consecutive elements. So here the longest length is 4. Similarly, here you can see the longest length is 3, 0, 1, and 2. Okay, here you can see the longest length is 6, 1, 2, 3, 4, 5, 6. Here you can see the longest length is 3, 9, 10, 11. Okay, so the constraints are n is less than equal to 10 to the power 5 and ei is from 10 to the power minus 10 to the power 9 to 10 to the power 9. So Shiva, how are you going to use a stack? So every time we need to find the smallest element, check for the consecutive element. So Pawan, I think your solution is very close to the optimal solution. Can you elaborate your approach a bit? Okay, so let me discuss Kushal's approach once. So we are on the same page, and I think you would be able to think of it from that point. Okay, so suppose your array is, let us say, 2, 1, 3, 5, 10, 4, 11, 12. Suppose this is your array. Okay, so I start checking from 2. So for 2, I check if 3 is present or not. So I can either linear search on it, or I can store all of these elements in a set and find it in O1 amount of time. Okay, so I see, yeah, that 3 is there. Okay, so cool. Now I try to check that is 4 present. So I see that 4 is present. So I got it. Now I try to see if 5 is present. So I see, yeah, that 5 is present. 5 is also there. Now I try to see if 6 present. So I see that no 6 is not there. Okay, so this series can't be expanded further. So I see that from this I get an answer of 4. Okay, now first I started my series from here. Now I would start my series from here. Okay, so I start from 1. Okay, then I see that is 2 present. So I see that yeah, 2 is present. Okay, so then I try to see that is 3 present. So yeah, the 3 is present. Similarly, 4 is present and 5 is present. Okay, so the answer for this is actually 5. Okay, now 6 is not present, so this cannot be continued further. Now I would start with 3. Okay, so similarly for 3, the answer would be 3 only. 3, 4, 5, that is the sequence. And for 5, the answer would be 1 only. Okay, then let me start with 10. Okay, so let us start with 10. So for 10, I would see that if 11 is present, so yeah, 11 is present. Then I would see that if 12 is present, so yeah, 12 is also present. Is 13 present? No, 13 is not present. So the answer is actually 3 from here. Okay, then I move on to 4. Okay, so for 4, I see that 4 after 4 only 5 is present. So for 4, the answer is 2. For 11 also the answer is 2, and for 12 the answer is 1. Okay, and I find the maximum of all of these answers. So you can see that the maximum is actually 5. So is the brute force approach clear to you guys? I start from every element and try to continue the series from here onwards. So first I started with 2, then I tried to find out that if I want to start my series from 2, then how long can it go? So I saw that 3 is there, 4 is there, 5 is there. Okay, so it can go up to 5, but after 5 I can no longer extend it. Okay, so similarly for 1 and 3. Okay, so can someone tell me what would be the time complexity of this approach? Yeah, it would be n square. Okay, and the worst case is actually like this. Suppose I had elements from 1, 2, 3, 4, 5 till n. Okay, so suppose I have all of these elements. So when I would start with 1, I would go to 2, I would go to till n. Then when I would start from 2, then again I would go till n. Then when I would start from 3, then again I would go till n. And then when I would start with n minus 1, then again I would go till n. Okay, so this would actually be the worst case in which the time complexity would be coming to be equal to n square. Okay, so is it clear till now, till here? Is it clear to everyone? Okay, so now see, what is the problem with this brute force solution? That I am like doing something repeatedly. So here I started from 2 and I saw that yeah, for 2 the maximum length is till 4 and it goes on till 5. Now when I started from 1, I came to 2 and then I'm again checking for 2. Okay, so that is why there is repeated calculation. Do you guys get it that there is repeated calculation in this case? Write a yes if you guys think that there is repeated calculation in this case. Okay, so see one thing. Try to think of this. Why can I not start from the smallest element? Okay, so let me explain this a bit. Okay, so if you guys understood it correctly till here, then you would be able to understand this. Okay, so let me use the same concept over here. Okay, so my array was 2, 1, 3, 5. So 2, 1, 3, 5, 10, 4, 11, 12, 10, 4, 11, 12. This was my array. Okay, now again I'm trying the doing the brute force only, but this time I will do it smartly. That I see. Suppose. Okay. Let me tell you. So I am going to start my series with 2. Okay. So here I can see I can go from 2, 3, and so on. I may reach some index finally, and after that I will not be able to go forward. Okay. So I am just trying to check that is there any element lesser than 2 with which this series can start. Okay, so I had just checked that if an element here is present or not. So I would just check if 1 present or not. If 1 is present, then I will not start my series from here. Do you guys get it? That before starting the series for any index, I would just check that if, so suppose my element is x. So I would just check before starting the series that is x minus 1 present or not. If x minus 1 is present, then I will not start the series from here. Do you guys get this? Okay, so see, before starting, so here I can start from 2, but I know that 1 is also present. So it is better to start from 1 than to start from 2, right? So I won't start from here. Okay, then I went to 1 and I saw cool, we can start from 1 and I would check that can we start from 1. So I would see that is 0 present or not. If 0 is present, then it is better to start with 0. So I see that 0 is not present. So then I would start from 1. Okay, so I started from 1. Then I saw that 2 is present, 3 is present, 4 is present, 5 is present. Okay. Now I went to the next element 3. So I checked that is 2 present or not. So yeah, 2 is present. Okay, so I won't check for 3. Now I would go to the next element that is 5. Then I would check is 4 present or not. So I would see that 4 is also present. Okay, so I would not start from 5. Then I would go to 10. Okay, so then I would see that is 9 present or not. So we see that 9 is not present. So we would have to start a series from 10. Okay, so we started from 10, then we went to 11, then we went to 12. Okay, then we can no longer continue it. So now we go to 4. So we see that Is 3 present? Yeah, 3 is present. So we won't start a series from 4. Okay. Now I go to 11. Then I check is 10 present. So I know that yeah 10 is present. So I won't start a series from 11. Okay. So now I go to 12 and I see that is 11 present. Then I see that yeah 11 is present. So I won't start a series from 12. So is this logic clear to you guys? When are we actually starting a series? We are starting a series from any integer x only if x minus 1 is not present in my array. Is this clear to you guys? Is this optimization clear to you guys? That we are starting some series only with x only if x minus 1 is not present in my array. Okay. And since since if x and x minus 1 both are present, then obviously x minus 1 is a better choice, right? So this is the optimization that we use to prevent repeated calculation. Just give a thumbs up if this is clear to you guys. This is actually a very simple problem. You just need to start thinking from the brute force approach. Yeah, it would be ON. And to be very exact, it would be O of 2n. Okay. So I hope the solution is clear to you guys. Yeah. So what the solution would look like is you just add all of these elements in a set. Okay. And when you are at any element x, just check that if x minus 1 is present in the set or not. Okay. So we are using an unordered set. So such would be O1. Okay. So we are just using an unordered set to see that x minus 1 is present or not. If x minus 1 is not present, then we would start our search from here. Okay. And if it is present, then we won't start our search from here. Okay. So the overall time complexity of the solution would be ON. Okay. And let me just give you the lead code link to the problem as well. So I have given you guys the lead code link to the problem as well. This is a lead code medium problem. Okay, and this is a good enough problem. So sir, set insertion okay, so Kushal, set insertion complexity is log n. Then you are using an ordered set, okay, or a tree set in Java, or a normal set in C++. But if you use hash set or unordered set, then it is O1. Okay, constant time. Since in unordered set, the data is not present in sorted order. Okay, so make sure that you write the code for this solution on your own. Okay, and get it accepted. Okay, this was a nice problem and an easy problem on sets only. Nothing fancy was required, and this is actually a very trivial problem that if you get this in an interview, you should be able to answer it. If you see what the problem with what was the thing with this problem is, I gave you the problem. You very quickly thought of an approach using sorting, which was n log n. Okay, and some of you may be trying to improve this sorting approach, but see sorting itself takes n log n, right? So obviously if we are using sorting in our solution, then it would always be n log n. Okay, so quickly disregard this solution, start thinking of something else instead of getting stuck over here and wasting time. Okay, start thinking something else. Okay, so this is something that I would suggest you. If you got some solution and you tried for 2 to 5 minutes and you are not able to optimize it, forget about the solution, try thinking the solution from some other perspective. So is this clear to you guys? So we can move on to the second problem. Okay, so this problem is actually easy, and the only concept required for solving this problem is arrays and sets. Okay, so let's move to the second problem. So the problems are actually arranged in increasing order of difficulty. Okay, so let's move on to the second problem. Let me write the problem first. Okay, and then we would discuss the problem. Okay, so you are given an array of n integers. Okay, and you need to divide this array into two subsets such that the sum of both the subsets is equal and every element is either a part of subset 1 or subset 2. Okay, so let me briefly explain you the question. So you are given an array, okay, and the size of the array is even. So n is even, okay, and you need to divide this array into two subsets, okay, so that the sum of both the subsets is actually equal, okay, and every element needs to be either a part of S1 subset 1 or it should be a part of subset 2. Okay, let me write the tell you by using a example. So suppose your array is, let us say, 2, 3, 7. Okay, okay, let us, yeah, let us say we have 10, and here let us say we have 7. Okay, so you can actually divide this array into two subsets of 2, 3, 7, and the other subset is 10, 1, 1. Okay, so sum of this subset is actually equal to 12 and sum of this subset is also equal to 12. Okay, so yeah, it is possible to divide. So you can return a true or you can print a yes. And if it is not possible to divide, then you can return a false. Okay, so let me write the constraints for this problem. Okay, so n, just a second. N is actually of the order 1000. Okay, and AI. Okay, so let us say n is of the order 100. Okay, and AI is also of the order 100. Okay, so first tell me if the question is clear to everyone, and n is even obviously. So here n is even. Okay, so I think question would be clear to everyone. So here you can say that yeah, it is possible. And if you see this, so let us say that 2, 3, 7, and let us say 5 and 3 into here. I think the answer is not possible. Okay, so you can check if it is possible or not. Okay, so suppose here we had 3. So here you can see that the answer is not possible. And can someone tell me that why is the answer not possible over here? So Mahavir, if sum is not yeah, correct Mahavir. Yeah, sum is odd. Okay. So the first and very easy to understand thing is that the sum of the entire array should be even. Okay. It can't be odd. So if it is odd, then we can directly print a no. But if it is even, so next thing is that it is even. So if it is even, can we directly write a yes, or do we need to do something extra? Okay, so yeah, what do you guys think? Can we directly write a yes if the sum is even? Yeah, we can't directly write a yes. Okay, so what do you guys think? How do we actually solve this part? See, this problem is when I would tell you the solution, then you would see that this is also a very standard problem present on lead code only. But this has been very slightly modified. So try thinking of a solution. So this is the original question and these are the constraints. See, you already observed that if sum is odd, then it is not possible. If sum is even, then it may be possible or it may not be possible. How would you check that condition? So, like, see, in an interview, don't be stuck for too long. Okay. Whatever you guys are thinking, suppose my solution is, let us say, having the time complexity n factorial, or it is exponentiation. Don't hesitate in telling the interviewer your solution. Okay. It is better telling something wrong than being stuck. So, Donny says sum of three element equal to total by two. Okay. So, I think what you mean is sum of any three elements is actually equal to total by 2. Is this what you mean, Donif? Okay, so suppose sum is, let us say, 2, 4, 8, and let us say 3, and here it is, let us say, 16, and here it is, 1. Okay, so here I don't think your condition would satisfy. So Kushal says sort that first n by 2 sum. So see, here you can see sort array then sum of first n by 2 element is less than total sum by 2. Okay, let me think of some test case for that. So if it is less than total sum by 2, then you are saying that it is possible, right? Okay, then it is not possible. Okay, okay. And otherwise it is possible, or you would make some further cases too. Okay, so see, if the array is, let us say, only this 2 comma 100, here the sum of first n by 2 element is less than total sum by 2. So here you are saying it is not possible, right? And if this is not the case, then you are saying it is possible. Let me think of some test case. Okay, so one more thing, that n need not be even. Okay, this is not the case. N may or n may not be even. Okay, so I just realized that it is possible to satisfy the condition even in odd length array. Okay, so yeah, so correct, that is your solution is correct. So let me give some counter test case of this. So odd array. Okay. So uh, Kushal, what would be like? Are you always taking the? See here, I also added like I told that it may not be even. So, are you taking the seal of n by 2, or are you taking the floor of n by 2? Like there is nothing like maybe. Okay, so it's like many of you are actually thinking of greedy solutions to this. See, if this problem had a greedy solution, why would I give you n less than equal to 100? I can give you n less than equal to 10 to the power 5, right? If it was possible to sort it or do something very similar. No interviewer won't give you time constraints, but if you ask, they can give you some in that they are expecting an n square solution or an n cube solution. Okay, so see one thing. What you actually need to do is, here you are given an array. Okay, and suppose I found some subset. Suppose the total sum is, let us say, 100. Okay, and I found some subset. So there is some subset in this array with sum equal to 50. Then will my answer be a yes or will my answer be a no? What do you guys think? That this is my array, okay, and in this array the total sum of the array is 100, and I found that there is a subset whose sum is 50. Will my answer be yes or will my answer be no? I think you guys would agree that the answer would be a yes. Okay, so what you need to actually do is the old problem has converted to another problem, that subset the subset sum problem, right? You are given an array. What was the subset sum problem? You are given an array, okay, and you are required to tell that whether a subset of sum equal to k exists or not. Now this problem has changed into the exact same problem, that you are given an array A, okay, of size n. Check if subset with sum equal to total sum of array by 2 exists or not. Okay, and this you can simply do using dynamic programming, right? Is the solution clear to you guys? Just write a yes or a thumbs up if the solution is clear to you guys. The size may not be equal. We don't actually care about the size, right? So we had to divide the array into two subsets such that the sum of both the subset is equal, and every element can either belong to part subset 1 or subset 2. Okay, so I think you were telling me the KD solution based on the observation that the size of the two subsets would be equal. Yeah, I think that, yeah, I think your approach would be correct there, but uh, that is the reason I told that n may not be even. Okay, so I hope this solution is clear to you guys. Okay, so like you would just maintain two things. First is the index, second is the sum, and here you can either take this element at the index position and your sum would increase by a of idx, or you can skip this and your sum would remain the same. So now someone asked me that how would I print the subset? Okay, so here you take the subset and here you do not take it. Okay, so see Atishay, when you are actually writing this DP, okay, so there are two paths that you can take. Either you can take this path, the first part, or you can take this part. Okay, so while you are writing the DP, okay, so how to apply this DP we have already discussed in our dynamic programming solution. You can check from there. Okay, so there are two options. So this is the first option that you take the element. This is the second option that you don't take the element. Okay, so you can check that from which path are you getting a true. So if you get a true, if you take the element, then just print this element out. If you get a true, when you don't take this element, then don't print anything. Okay, so this is how you can print the subset. Is it clear now, Atishay? How you can print the subset? Okay, so while you are making the choices, just see that from which choice are you getting a true. Okay, similar to how we print in backtracking. Okay, but here the only thing that has changed is you have applied memoization, so it won't be an exponential solution. Okay, so this is the third problem. Okay, so before I tell you the third problem, how many of you guys know about minimum spanning tree? Okay, I'm just asking the definition. I'm not asking for any algorithm to find the minimum spanning tree, Prim's algorithm, Kruskal algorithm. I'm not asking about that. Okay, so for those of you guys who don't know minimum spanning tree, so see, suppose I'm given a graph. Suppose this is my graph. Okay, and the weight of this edge is, let us say, 3, here it is 4, here it is 5, here it is 6, 7, 8, 9, 10. Okay, so you can actually convert this graph into a tree. Okay, so let us say this node is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, so what, see, everyone knows what a tree is, right? That every node is connected to other node and there are n minus 1 edges. So suppose I consider this as 1 is connected to 2 and 2 is connected to 4, 4 is connected to 5, 4 is connected to 3 and 4 is connected to 6. Okay, so I have removed some edges from this graph and converted it into this graph. Okay, and this is a tree. Okay, and this is a, we can remove some edges and generate a tree from a graph. Okay, and this is not a normal tree. In this, all the nodes are connected. Okay, so this is the first property, that all the nodes are connected, and obviously the edges should be present in the original graph. Only then you can do that. So another tree that is possible is, so suppose you start from 2, so you connect 4, then you connect 5, then you connect 6, then you connect 3, then you connect 1. So this is another possible tree, right? Here one is was connected to 2, here one was connected to 3. So this is, so the, suppose this is tree 1, this is tree 2. So there can be many such possible trees, right? So what I want you guys to tell me is, so like, do you guys get like how am I constructing these spanning trees? Forget the word minimum for now. Do you guys get how am I constructing these spanning trees? Okay, so I am only talking about spanning trees. Forget the word minimum for now. Okay, if you are not able to get, just write it out in the chat. I will explain you again. See, don't worry if you have not studied minimum spanning tree. The question is not based on minimum spanning tree, but you need to understand what a spanning tree is. Yeah, it covers all nodes and has no cycle. Okay, yeah, we are removing loops, that also you can say. Okay, so I think it would be clear to you guys now that what a spanning tree is. You would be given a graph and you can remove some edges so that you get a tree in which all the nodes are connected and the number of edges is n minus 1. And you can also say that there would be no cycles and there would be no loops. Okay, so this is what you actually mean by spanning tree. Okay, so how do I actually define the cost? So here the edge is 3, here edge is I think 4, 5, here the edge is 7, here the 4 to 3 edge is 6, 4 to 6 edge is, let us say, 10. Okay, so edge is 10. So what would be the cost of this is 3 plus 5 plus 7 plus 10 plus 16. Okay, so what is that? 8, 15, 25. I guess it's 31, right? The cost of this tree, of this spanning tree, is actually 31. Are you guys getting how am I calculating the cost? I'm just adding the sum of all the edges, edge weights. Okay, so does everyone agree with the fact that the sum of this spanning tree, the cost of this spanning tree is actually 31? Okay, similarly, if you try to calculate here, so between 1 and 3, the edge cost is 10. Between 3 and 4, the edge cost is 6. Between 4 and 6, the edge cost is 10. Between 4 and 5, the edge cost is 7. Between 4 and 2, the edge cost is 5. So if you try to calculate the cost for this, so it is, I think, 6, 5, 11, 21, 31, 38. Okay, so similarly, you can try constructing all of the possibilities. And what minimum spanning tree means is that spanning tree whose cost is minimum. Is the definition clear to you guys? So minimum span. So first of all, what we learned was spanning tree. What is a spanning tree? You have a graph. Okay. So from this graph, you need to construct a tree such that all of the nodes in this tree are connected and there are exactly n minus 1 edges. Okay. And we can say there are no cycles and there are no loops. Okay. So this is the definition of spanning tree. What is a minimum spanning tree? That out of all of the possibilities for the spanning tree, which is that spanning tree which has the minimum cost. Okay, by cost, what I mean is the sum of the edge weights. So just tell me if the concept of spanning tree as well as minimum spanning tree is clear to you guys. Okay, so see, now let me tell you guys the question. Okay, If you don't know how to find the minimum spanning tree, it does not matter. This question is not about finding the minimum spanning tree. That is the first thing. Okay. So let me tell you the question. So you are given a graph. Okay. So weighted graph actually. You need to find the minimum cost spanning tree. Okay, so you are given a graph and you are told to find the minimum spanning tree. Now you may be thinking that I just told you that this question is not about finding the minimum spanning tree. Okay, so let me elaborate the question completely. So suppose this is your graph. Let me write it in another page. So suppose this is your graph, let us say. So here let us say weight is 3. Here let us say weight is 5, 7, 10, 15, 21, 31, 11. Okay, so one spanning tree could be, so let me name these nodes 1, 2, 3, 4, 5, 6. Okay, so it could be 1, 2, 3, 4, 5, 6. So what are the edges used over here? So 3 is used over here, 5 is used over here, 10 is used over here, and then 15 is used over here, and 21 is used over here. So how do I define the cost of this spanning tree? Is the maximum edge weight that is used. So I define the cost of this tree as 21 and not as the sum. So even if you knew the minimum spanning tree algorithm from before, you will not be able to solve this. Is the question clear to you guys? How have I defined the cost? The cost is actually the maximum edge weight of the of the spanning tree that you construct. Okay. So what is the cost? Maximum edge weight of spanning tree. Is this question clear to you guys? The first thing I want to know if the question is clear to you guys. So this is a graph. So you can definitely come up with many spanning trees similar to what I just told you. But there, the what was the cost defined like? Cost was the sum of all the weights of the edges. Here I have not defined the cost like that. I am saying that cost is the maximum edge weight in the spanning tree. So even if you knew how to calculate minimum spanning tree using either Prim's algorithm or Crystal algorithm, this will not work. Maximum. So what there are many there are many spanning trees, right? So here I showed you a graph, right? So here you can actually find the construct this as a spanning tree. This also will be a spanning tree. So similarly, you can construct many such spanning trees here also, right? So what I can do is I can connect one to let us say 2, and 1 can also connect to 3, and 4 can connect to 6, and 6 can connect to 5. This is also a tree, right? So you need to tell me what would be the cost of what would be the cost of minimum spanning tree over here. Atisha, is the question clear now? So here cost is 21. Here there would be some cost. So I want to know out of all of the cost, what is the minimum possible cost? Is the question clear to everyone? Just write a yes or a thumbs up, anything. Just so I know that the question is clear to everyone. Okay. So now try thinking of a solution. This is a nice problem, and I think this was asked in some previous code forces round. A very old code forces round, and I think it was div 3 D or E, I guess. And this is actually a very easy problem. We need to consider then all possible spanning trees and take minimum. Yeah, the brute force approach is obviously construct all of the spanning trees and find the minimum of the cost. So Atisha, we have to find maximum. Okay, so you have to find the minimum possible spanning tree. You have to minimize the maximum weight actually, Atisha. Okay, so I think it is the problem is still not clear to some of you guys. So suppose it is like this. Suppose this was your graph. Here let us say edge was 3, here 10, here 20, here let us say 11. So you can actually consider a tree like this. 1 is connected to 2, 2 is connected to 3, 3 is connected to 4. So what are the edges over here? 10, 20, 11. Okay, so similarly you can construct another tree. Let us say 2, 1, 4, 3. So what would be the cost over here is 10, 3, 11. Okay, similarly you can construct another. So let us say here you have 1, here you have 4, okay, and here you have 2, and here you have 3. Okay, so what would be the cost over here? So here it is 10, here it is. Okay, so this is just the same as this thing. So you can actually just a second. So let us say 3 is over here and 2 is over here. Okay, so here we have edge 20, here we have 11, here we have. So what do you guys think will be the cost of this spanning tree? 11. This spanning tree. It has weights 10, 20, and 11. 20, right? Since you have to consider the maximum weight. What do you guys think will be the cost of this spanning tree? Here it would be 11, right? Since the maximum edge weight is 11. What do you guys think will be the cost of this spanning tree? It will not be 11, right? We have 20, 11, and 3. So what is the maximum? 20. Okay. So out of all of the possibilities, what is the maximum minimum cost? The minimum cost is I think 11, right? So the answer is 11 in this case. So some of you are saying every node's edges take minimum mark visited and then find minimum of minimums. I think this is what you mean. Every node's edge take minimum mark visited and then find minimum of minimum. Suppose here it is, let us say 2, here it is, let us say 3, here it is, let us say 4. So, Kushal, what edge would you take in the first go? And Atish, how would you use a max heap over here? So you would start from 1, okay. Then you took 2. Then what you would do? Okay, so I am marked with 2 as rejected. Then what would I do? Yeah, this edge has been marked with rejected. Okay. Then note 2. Okay, then only 5 is option. Yeah. So what option will you prefer over here, Kushal? You can't just take the minimum and expect to get the to get the minimum spanning tree, right? So here, if you see that the answer is actually this. Okay, so you took both of them and not just the minimum, and the cost is actually 4. Is it clear, Kushal? Okay, so any other solution? Someone was saying max heap. How are you going to use max heap? Take one neighbor and push all its neighbor weight in minimum heap. Okay, so two this went in min heap and this went in min heap. Okay, then so I think it would work for this case, but it won't work in general since the minimum see and also okay. So let me give you a test case where this will not work. Okay, so Like this solution will not work. I am not able to find a counter test case, but if you try enough examples, then you would figure out that this solution will not. It would mainly be the case when there would be cycle and you would skip in order to take the minimum. You would actually add this edge, but it would actually be forming a cycle. And in order to remove this cycle, you would have to take a edge weight greater than what you would have previously taken if you would have considered the not the smallest weight. We can find n minus 1 its minimum value. We can find n minus 1 its minimum value, but that does not mean that we would take all edges from 1 to n minus 1, since there would be cycles also. And that is why this algo is not working, because when there would be cycles, then we would not be choosing the next minimum value. We would be choosing some other value. And it may be possible that if we create this cycle and remove that edge which was due to which the cycle was being created, and then take this edge, we can get a more optimal answer, right? Okay, like if you think about this, then suppose mx is actually the maximum weight of all of the edges is, let us say, mx. Okay, so one thing I know that the answer is between 1 to mx. Is this thing clear to you guys, that the range of the answer is between 1 to mx? Okay, now try to think using this. Okay, so suppose I found out mid. Okay, okay, so let my mid be x. So what I do that in my graph, I would consider only those edges which have a value lesser than x, which has a weight less than or equal to x. Okay, then whatever graph I would get, I would just check that is the number of connected components equal to 1 or not. If the number of connected components is equal to 1, then yeah, we can get a minimum spanning tree with weight x. And if we can get a minimum spanning tree with weight x, I would try to search in the right half. And if I'm not able to get a minimum spanning tree with weight x, okay, it is not possible. So obviously, x plus 1 or x plus 2 is also not a possible answer. So then what I would do, I try to find a weight in the left half. Okay, so you can just binary search, and for each mid value, just check construct the graph and check the number of connected components. If the number of connected component is 1, then yeah, it is obviously possible to construct a spanning tree, right? So the time complexity of your solution would actually be log of max of weight of I into n. Okay, so pseudocode would look like this. My low would be actually 1. Let me write it clearly. Okay, so my low would actually be 1. My high would be max of wi. Okay, then I would just write while low is less than equal to high, and would have an answer variable. Okay, so I would get mid first, so mid equal to L plus h by 2, and I would check that check of if check of mid is true, that is it is possible to construct a spanning tree in which the maximum edge rate that is used is actually equal to mid. Okay, so the edges that I'd be using, the weight of those edges would actually be less than or equal to mid. Okay, so if this is a true, then what I would do is this is a possible candidate for my answer. So I would initialize answer with mid and search in the right half. So how do I search in the right half? I would just put L equal to mid plus 1. Else, if it is not possible to construct a spanning tree using only these edges, then I would reduce my search space to the left half. So then my high would actually be equal to m minus 1. Okay, and this check function you can just implement using DFS and check that the number of connected components is equal to 1 or not. Okay, so the time complexity of binary search is actually log of wi, and this check function is actually implemented in on, and to be very precise, it would be actually implemented in o of n plus m. Okay, so it would be n plus m into log of wi. So I hope you got the idea of the code as well. Okay, so see, you don't need to construct the new tree every time. what when you are doing DF, just construct the graph once and only consider those edges in DFS which have a weight less than mi. Okay, so this is actually a nice question, and this question has concepts both from binary search on answer, which is a very famous topic for interviews, as well as graphs. Okay, so this is I think a good question, a nice question, easy question. If you think about it for around 5 to 10 minutes, then I think you would be able to get it. Okay, so like try to think about binary search. So here you already know that what the range of your answer, what is the range of your answer. Okay, so just try to think, if you found the mid, how can you evaluate whether you can reduce to the left half or the right half? How to be sure that each edge is covered? What do you mean by each edge is covered? Like, why do we need to cover each edge? So see, each node would be covered. That is the reason why. That is the reason, right? Why the number of connected components is one. See, okay. So let I think you are getting it wrong. So suppose this is your graph. One. Let us say this is one. This is two. This is three. This is four. Here it is 10. Here it is 20. Here it is 30. Here it is 40. Okay, and you are trying to like your, let us say your mid value is, let us say, 20. Okay, so we know that this this edge is possible, and this edge is possible, and this edge is not possible, and this edge is also not possible. So your graph would actually be like this: 1 and 2 is connected, 1 and 3 is connected, and 4 is left as it is. So here the number of connected components is 2, right? That is why we have the condition that the number of connected components should be 1. Okay, I hope you guys got this. So that's all about this session. If you guys have any questions, then you can ask me doubts for around 2 to 5 minutes, after which I would end this session. Okay, so if you see that the level of questions was good, the first question although was LC medium, the second question also I would rate as LC medium, and the third question can be considered LC hard because it involved concepts from both binary search and graphs. Okay, so these are the level of questions based asked in product based company. Okay, so I hope now you have some decent amount of idea, like uh, what sort of questions are being asked in good companies. Yeah, first question is tricky. First question is definitely tricky. But the thing that you need to learn from that question is, if you are stuck too long on a single approach, then leave that approach. It is better to leave that approach and start thinking something else. Okay, here we saw that we quickly came to an optimized solution in n log n. Okay, but how did we actually get the final solution? By starting from the brute force, right? If we would have been stuck in the sorting solution, then we would never have been able to convert us to. We would never have been able to get an ON solution. Okay, so don't stick to a particular solution for too long. Okay, 3 to 5 minutes is maximum that you should stick to a solution. If you are not able to convert it into a more optimal solution, leave that approach right there. Okay, and like if you give 5 minutes, if suppose if you give 5 minutes, okay, and you are still and you are somewhere close to the approach, and your approach can be converted to an optimal approach, then the interviewer would definitely give you some hint to convert it into an optimal approach. If you are not able to think it on your own in 5 minutes, and if the interviewer also doesn't tell you anything, then that means that's a dead end. Okay, and you won't be able to get a solution if you stick to that approach. So I hope you guys found the session helpful, and like I plan on taking on more such sessions. Okay, so you guys can. I'm just creating a poll, so you guys can just answer true if you want me to take more such company specific sessions on product based companies, Amazon, Google, all of these companies. Then answer a true, and you can answer a false if you think that we should not be taking more such sessions. Okay, so yeah, I'd share the implementation. Don't worry. How to command basics. Okay, so for commanding basic, you should start from the basic, obviously, and like you should first get familiar with the language. Okay, do you mean DSA basics or the language basics? Okay, so see, For the language, you can go to any website. Like, suppose you are trying to learn C++, then you can just search on YouTube C++ tutorials. I think there are many such tutorials by many people. Okay, or you can just start reading from the documentation. Or there is a site called Program is there also you can learn C++ basics. There are many such sites. Just Google it up. Okay, see, a language is something very trivial. You would find video-based content as well as text-based content, everything. So I think none of you have any doubts. DP doubts session. Okay, so see, if you have a decent number of you guys have done the DP problem, then I will take a doubt session. Otherwise, it doesn't make much sense since quite a good number of you have not even done the mixed problem solve mixed so much problems till now. And like if you are stuck, okay, then you can just ask in the group only. There only I can discuss, and we can see. Like at the end, I have around 5 to 10 spare minutes, so we can discuss the solution there itself. Okay, since not many of you are actually doing the homework problem, so I don't think it is of any use to take dedicated sessions to doubt solving. So at the end of every session, I have 5 to 10 minutes, and you can ask your doubts there, and I would explain you the solution as well as the code. Okay. Okay, so that's all for this session. Okay, and the next session that I'd be taking would be on. Also, I was not aware of it, so I joined this few minutes. Can you share the links to the question? Okay, so see, these questions were asked to one of my friends in Amazon interviews. Okay, so I could only find one question on lead code. Okay, the other question you can just Google it up. You would get the link. And the third question is actually a question that I solved somewhere long back in a code process contest. So I don't have the link for that as well. Okay, but if you plan on writing the code, you can share your code in the group, and if it is, I can check your code. Okay, don't worry about that. Okay, so the first problem I have pinned the link, and you can check it from there. Longest consecutive element sequence. It's a lead code problem. The second problem also you would be able to find on lead code only. So the problem is actually named partition array into two parts or something like that. I don't actually remember the complete name, but the third problem I completely don't remember which contest it was, how many months before it was, or anything like that. Okay, but I think the code for the third problem is trivial. Once you know the concept of binary search or answer plus finding the number of connected components. Okay, so yeah, like make sure that you guys actually practice a good number of questions on binary search or answer. This is a very important concept. Like just now I told you that the problem involved both binary search and graphs. Okay, so this is actually a very important concept, and like even see binary search is also applied in dynamic programming problems. So see, binary search is a very nice thing to know. Okay, so make sure that you have a decent amount of practice on problems on binary search. Okay, so on Sunday I'm also going to discuss two problems on binary search yeah, along. So we would be starting with the basic knapsack problem, 01 knapsack problem that most of you guys may be knowing. Okay, but we would also be seeing a different version of this problem using binary search plus dynamic programming. So that is the power of binary search. It can be applied with dynamic programming. It can be applied with graphs. So we would be seeing binary search or answer plus dynamic programming. Okay, so we would be seeing actually variations of 01 knapsack. The standard problem 01 knapsack problem, most of you guys would be knowing, but we would be actually be seeing variations of binary search on answer plus dynamic programming on 01 knapsack. Okay, so this session I plan to take on YouTube on our channel Uncode Competitive Programming. Okay, and we would be having a lead code weekly contest discussion also this Sunday at I think around 1 or 2 p.m. We missed the last contest discussion, but this week I will definitely be doing this. Okay. So I think that's all for this session. If you guys have any doubts, you can ask or we can end this. I hope you guys found the session helpful. And you can tell me some more companies of which you would like to discuss questions on. So Vijay, can you share the questions of share chat? I don't actually have the link to the questions. So Infosys, does Infosys ask coding questions? I think it asks aptitude based question only, right? So you can join my Telegram group for those of you guys who haven't already at t.me/AnujCP. Okay, you can join my group over here. Okay, so there you can like share the problem, share the company name as well as some problem list that you guys have. Okay, so that's all for this session. Let's meet in the next session. Take care, all of you. Bye bye.